Greetings, Nikki. This is Mr. Caslin. Want to give you a quick overview of proofs. Now, proofs is really a long, complicated topic, and there's lots to do with it, and lots you need to be prepared for to be able to do, and lots of background to them. So I can't really, in a short period of time, teach you how to do proofs, but let me get you started on the concept of how these proofs work, and we can talk about it more when we get together. Now, to do proofs, really, your teacher should be prepping you with each chapter. With each chapter and unit you do, you're adding on to your list of information, your tool bag, if you want to call it that, for proofs. Basically, all the definitions you're learning, the theorems, the properties, the postulates. The whole concept in geometry is every theorem that you prove, you can then use that theorem to help prove other theorems. Euclid, the father of geometry, basically wrote an entire book basically on how to use theorems to prove other concepts in geometry, and all these geometry books are based on the original work that Euclid did. Anyway, but what you have to understand is your teacher should be giving you, as you learn more material in each unit, you should be adding to your list of definitions and theorems and properties that you can do for proofs. So this one here is a basic proof that we can get started with. It's called a two-column proof because you have statements and you have reasons. Every time you make a statement, you must give a reason, give a fact that you can use to help substantiate that statement. So in every proof, you're given information. You should never get a 0 on a proof because the first line of a proof should always be given. They give you the fact that AB here is equal to DE. And what's the reason for that? Well, as you said here, the reason for that is you were given that information. Okay, information can be given in a text, or it could also be given in the picture. So any information they give you in the picture can also be used as given. Okay, now when you're doing a proof, they're telling you now that if you add BD to both of these line segments, you're actually using a concept from algebra. Okay, so part of your tool bag, if you want to call it that, or your reasons that you can use for geometry proofs are a bunch of algebra statements. You have an addition property in algebra that says if you add something to one side of an equation, you can add it to the other side, and it'll still make your equation true. So in this first step, you're actually using an algebra property. You're adding BD to both sides of your equation. So instead of segment addition postulate, what you're doing here is you're using the, excuse my writing with my mouse, it's not very good. You're using the addition property of equality. Okay, so you may have, or you should have, gone over these algebra properties at the beginning of geometry to review them, and you should have them on your list of items you can use for a proof. So first item was given, and then you're using the addition property of equality. All right, now what you're saying in this next statement is you're saying that if you take AB and you add to that the line segment BD, you now have the segment AD. Okay, so you're basically saying two pieces of a line segment, if you add them up, they create the entire line segment. Now that's the segment addition postulate, is what you're using in this third line. So on your list, you should be, like I said, you should be working with, your teacher should be giving you reasons to use for proofs, and one of your postulates that you've learned up to this point is the segment addition postulate. You can use that in a proof. So in this line, you would then say, he probably would want you to spell it out, but for now, we're just going to call it the segment addition postulate. So now we know that AB plus BD is equal to AD, and then DE plus BD is also equal to BE. So these two pieces equal this entire segment. All right, now, when you're looking at this statement, think of the fact that this looks a lot like if A is equal to B and B is equal to C. Does that sound familiar from algebra? It should be. What you're doing here is you're using the transitive property. Okay, you're going to conclude that AD is equal to BE. So you can use the transitive property. My handwriting is just Terrible with a mouse. All right, so you're going to use basically the transitive property from algebra. So there are many, many proofs. I can't tell you one way that's going to help you solve all of these, but again, it has to do with building a list of items. These items can include definitions, theorems, properties, and postulates, and use these as your tool bag basically to help you have reasons for proving proof statements. So we'll cover this a lot more as we go on this year. In fact, algebra used to be all about, not algebra, the geometry course used to be all about proofs and proving everything as you go along. They don't do proofs as much anymore, but maybe with each unit we'll pull out a proof and show how that would work. I hope this helps. Again, it's just a starter, but we'll have to do a lot more of this year.